I work with the IV&V facility in Fairmont, West Virginia, and I do code analysis. That's my specialty. So for years, we've been looking at source code for flight software, and there have been some changes that have been coming on through time here. And one of the changes is a lot of the source code is now not being written by human beings. And what I'll be talking about here is how we go about code verification and validation, and how that is changing since we're moving from what people normally write to what machines are writing, and give you some experiences that we've had. In the beginning, people wrote flight software in C, and we have Noah's quaternion transformation here that you can see. And the way we go about doing code analysis, we have two different approaches to it. One is to use static analysis using Clockwork, LDRA, Flexilent, those kinds of things to find problems that get through the compiling process. Normally they have to compile it to run it, so there's a lot of errors. They can find themselves there. And then we can go through, run these tools, and they produce thousands of warnings, only a few of which are really real. So it's a very tedious process of going through these warnings to make sure that we only produce issues that we report to projects on real issues that really are really there. The other thing we do is what I refer to as semantic analysis, take requirements or design elements and map them into the code itself to make sure that what they wrote is semantically correct with respect to what they said they were going to write. Once again, that is also a manual process. And code generators have been around for a while, but they're becoming more and more a part of the flight software development process. And they can take any input in some form, run it through a generator to produce a source code that then gets compiled, which you could almost think of as another code generator. So these inputs can be in the form of UML diagrams. A lot of people are familiar with Rhapsody, Rational, have products for doing that. Some people have written their own tools that take their own kinds of diagrams. Certain kinds of text files like XML files can be used, and Excel files are sometimes used, such as timeline management functions can come out of Excel. You run it through your generator and you get some C code. And when you're looking at manually written code, you read the code. You map requirements to the code itself. And one of the questions we asked ourselves is, do we treat the generators like we treat compilers? We don't look at the machine code that comes out of the compiler. So when we're looking at the auto-generated code, should we look at the code or should we look at the products that go into writing the code? And the answer we've come up is yes and no. Great answer. Sometimes it's better to do one, sometimes it's better to do the other. Part of it comes down to, is it a COTS product? Can you trust it? You know, a lot of the code generators that were used on the Mars Science Laboratory were Python written by their people, so they didn't have a pedigree that we could go to like we could with rational products. So in that case, we wanted to check both ends. And another problem you run into is how do you know what you're looking at? Did this code come from a generator or was it written by hand? And sometimes it's easy to tell. MATLAB actually puts nice headers on the top. You can tell that's where it came from. The roll your own stuff, not so much. And MATLAB's been around a while. Lots of guidance nav stuff has been done in MATLAB for years and years. And we don't do a lot of the semantic analysis, reading MATLAB code. Has anybody tried to read MATLAB code? Yeah, it's not well commented. The algorithms are really hard, and it doesn't really do nice things with variable names. Tends to offset your increments and your arrays too. So we generally didn't look at MATLAB particularly. We do the static analysis, and sometimes you can find logical problems in the code that were in the model that made it through, okay? And one of the newer approaches that's coming up is this concept of dictionaries. And once again, this comes from JPL. They would have dictionaries for their commands, telemetry, faults, and they would store this telemetry information in XML files, which they can manage through HTML servers and so forth, and then take those XML files to generate code. All right, and a little bit about XML for anyone who might not know what it is. XML is just a text file. It stores hierarchical data, unlike a database which stores relational data. It allows defining a schema which can be used to verify that the XML file is correct, has all the right parts in all the right places, before putting it through the next phase of trying to generate code or whatever else from it. And it's, quote, human readable if anybody's tried to read a tagged language. And XSLT is the XML transformation language. And it's in XML to work on XML. But it's a language that takes data in XML and will transform it into some other text, either XML, HTML, just raw text like a PDF file, raw text. What I used that for was dynamic web pages. You have your presentation layer is the XSLT, which defines out how everything should look. You get your data in XML, and then you could produce a dynamic web page, much cleaner than you can with like JSPs or ASPs, where you're kind of mixing the code and the presentation all together. So what JPL was doing was they would have these XSLT files to convert your command dictionary, for example, into something you can look at on a web browser, or a command manual that would be present in the operations room, and also to pass it through the code generator to produce your source files. So this makes all your final products consistent. And if you want a new command, you add it into the command dictionary, and it comes out in a source file. And what they would do is it would produce all the enumerations, all the parameter handling, and produce stubs for the developer to go in and write code inside the stub that actually performed what the command was doing, but they didn't have to write all the domain and range checking on the parameters and all the other things you have to check for when a command comes on board the craft. And one of the results that came out of this, when you look at the code that was produced, at least by their stuff, unlike the MATLAB code, you could actually read it, because they had to use well-labeled identifiers, because the developers had to use these identifiers elsewhere in real code. It was clear. It produced code efficiently in that they would rerun this every time they would make a new build. It's very inefficient with respect to SLOC. They would claim 80% of their code was auto-generated. But if a real person had really written it, they would be able to fold a lot of the common functionality together and it'd shrink it down to a tenth that size, really. So, and how did we deal with it? Well, first we did a black box approach on the generators because we couldn't trust them. So we took some XML samples, what patterns were they giving these generators, and looking at the code that came out. to see if the expectation we had was met in the way it was forming the patterns that were needed to produce effective functional code. And we also passed it through the static code analysis once it came out. And for this case, we did trace requirements into the actual resulting code, not into the dictionaries themselves. Down the side here, you've got labels from Clockwork of the different kinds of warnings that come out. Across the top are the different mechanisms that code was produced. The ones covered up in blue so you can't see the names of them are their autocode generators. And the one down the middle is the hand-coded, okay? And you can see the pattern. You get this random spread across hand-coded stuff. And you get these pockets of somethings going on with the auto-generated code. Now, a lot of times with hand-generated code, you got to check every single warning that comes out because any one of them could possibly be, you know, if you only got a 5% hit rate, you can't do a sample of 10%. You have to look at everything. But with the auto-generated code, you could actually check out samples of these pockets to see if the pattern was really relevant to something. A nice time saver. Some of the things that we did find. The auto-generated code would do things that people would never do. One thing, it would increment pointers after it was done using them just because that was part of the pattern of the block that came out. It would put switch statements in with only a default because in general the pattern would have options, but that particular command didn't have options, so there were no cases. So you'd find these defaults with no switch, with only a default process. We did find that one of the problems when they built one of their generators was it was checking the maximum value of the range to see if the passed-in parameter was not outside the upper end of the domain, but they never checked the lower end of the domain. It's one of the problems we reported to them. And the nice thing about that too is also if you only had to report one issue for a whole batch of things that happened over and over again. The first project that they used this on, they had command requirements that generated command dictionaries produced by their engineers that went through the generator that produced the flight software plumbing for all the command handling, okay? And you had this nice transitive relationship from the requirements through the dictionary all the way to the resulting code. So we could check the code to verify the requirement was implemented, okay? And there was one case where we found that they had dropped all the mode handling by looking at the code. The requirement said you could only use this command in X mode, and there was no restriction on that. They had dropped it out of their process. So we found that using this. The next follow-on project to that, they didn't have command requirements. They would have some parent requirements that would just point to a generic requirement that said the command will be in the dictionary. So there was no trace between the dictionary itself and the command requirement. So we lost that kind of flow. And one of the problems we're still working on solving is to get that transitivity back so that we can actually do the analysis properly and be able to figure out that, you know, this is actually implemented over there. And as I've moved on to a new project where they're actually using, I believe it's Rhapsody. They're using Rhapsody. And you can get model-generated code from UML in several ways. One is to fully model the generated code. So everything is in the model. It generates the code. And you can probably trace all your requirements, design elements, into the Rhapsody model. I've worked before with the rational products where we do the object-oriented layout, the classes, the methods, the data elements, all the inheritance, all that. But then you'd have to go in and write all the code yourself. So it's partially generated, at least generates the architecture for the software. But the code, the actual logic is all handwritten. In the case that I'm working on now, it's kind of half and half, in the sense that all the functionality is in Rhapsody, but you can embed handwritten code inside the Rhapsody models that can get sucked into the actual code that comes out the other end. And one thing we haven't figured out is how to identify the stuff that's really written by hand versus the stuff that the generator put out. And we have put this through static analysis, and once again, just like with the MATLAB, you can find out problems in the logic of the model itself by looking at logical problems identified by the static analyzers on the code side. And I believe that's it. That's the experience I've had with auto code generation. Jeremy, you got your mic on?
No questions? No, you're not off to the hook that easy.
Oh, yes, sir.
This sounds to me, it sounds very familiar in the days when compilers weren't exactly trusted. So
Yes.
we could look forward to the possibility of code generators being a lot better.
And they probably will in time. MATLAB's very mature now. Yes, sir.
You had mentioned that the MATLAB generated code that you looked at was not really very readable. They are known to have hundreds of different configuration options to customize the stuff that comes out.
Yes. Okay.
Do you have much experience with changing those features, or was it you were just looking at a product that someone had delivered?
I am always looking at a product that somebody else has delivered. There was an incident just in the last couple of weeks where we were looking at MATLAB generated code, but it did have documentation on the variables and what the units were. And all of the units were in feet and pounds, except for these antenna locations that were all in meters. So we reported that to the project, and they are fixing that so that we don't have another Mars problem. Yes, sir.
So have you been looking at the code evaluations in lieu of secure coding practices? Having generated code, or is that purely human add-on at that point?
The facility itself is having to start to deal with security. I haven't been, because I've pretty much been restricted. I like playing with flight software, where hacking's not been an issue.
Well, not necessarily hacking, but bad programming practices that would allow hacking or undesirable behaviors to happen.
It's not, in fact, we actually deliberately didn't look at a lot of those warnings because we thought that the risk was so low. That's coming back into play because the facility is actually working on the New York City 911 project. And we're also looking at ground software now, where the probability of that becoming an issue is much, much higher.
You have a look at the search secure coding practices website.
Okay.
Some good stuff on there.
Thank you. Yes, yes, sir.
In the pie chart on the clockwork examples, have you made any observations on defect density, those areas where autocode had those little clusters? Looking at a density per line of code compared to the hand code to see if you see kind of out of bounding from one set of code generators versus hand code?
I think I did that, but it would have been like 4 or 5 years ago. And I don't remember any results coming out of it that were effective at producing a conclusion of some kind. I just totally didn't answer your question.
No, I think, because when you saw that, it was like 9,000 errors in the hand code, but you didn't know that it was 9 times as much code as the other one. I was just
Well, and in that particular, for that particular chart, there was about a 50-50 split between the other, everything else and the hand-coded stuff. It would be nice to see a density thing to see if that held any informational value.
Obviously, it's not valuable when they generate 10 times more code than hand code. But
Right.
you have to normalize it somehow.
And eventually got to that point. That was early in the project. And since it's been cleared many times, I keep using it. Yes, sir. Huh? Yes, you.
You know my name, so I didn't even say it.
Hey, Stephen.
I was just curious, because I know that a lot of projects, we're seeing more projects using code-generated tools, especially model-driven development. And what I'm wondering is as you get new versions from the software, did you look at or develop any methods that would allow you to look at how the models themselves changed and maybe run those differences through something like clockwork as opposed to just running the code again, then having to look through all those potential false positives?
I'm ringing. Okay.
Your phone.
We have that is becoming important on the MPCV project with MSL, because most of the models were the XML files and a few Berkowitz. What was the first guy who was here from JPL?
Oh, no.
Benowitz. Yes, he you know, his stuff came out of, I forget which tool it was, but it wasn't. It was something that they Magic Draw.
Yeah.
And we did not do anything with that because either it was too small a sample set to deal with, and he was writing his own generator for that, which everything could vary with time. With the Rhapsody models in MPCV, where everything is being generated from the models, that's going to be something we need, that is a problem we need to solve. I don't know how you do differences across, I can do difference across text files. I don't know how to do it across UML files. Yes, sir.
One of the things I do when I'm writing is a fair amount of spell checking, but I use a lot of words that aren't in anybody's dictionary.
Yeah.
So I actually keep a record of the output so I can compare the new output to the old output, see what's changed. That's one possible way of doing this.
An obvious solution. Thank you for that.